Hi class, just a quick introduction to Chapter 3, which is about temperature. And we're going to start at my favorite weather website called wonderground.com. Let's have a look first at this weather events pane. It gives us the record high temperature for June 23rd and the record low temperature for June 23rd. The record high was 117 degrees in Pakistan. Notice that they don't give units of measure. How can we get away with that? Well, in the United States, pretty much everyone uses Fahrenheit. Most of the rest of the world uses the Celsius temperature scale, but I think in the US we can pretty much assume that when a temperature is given, it's going to be in Fahrenheit, unless you're reading a scientific journal article or a report or something from another country. So 117 degrees, that's pretty hot in Pakistan. The record low for today was minus 67 in Antarctica. What season is it in Antarctica on June 23rd? We're in summer. Antarctica is in the southern hemisphere, so we know that right around the June solstice, it would actually be the middle of winter in Antarctica. So they're hitting lows. The lowest today measured there was minus 67 degrees. So today, let's go to the map section. We're going to go over here to current conditions and have a look at some temperature maps. Notice on the right, we can pull down this menu and choose different regions, but we're going to focus on the United States for right now. We're going to pick temperature. And we have 3 maps to look at, but we're going to start with just a temperature map. So this is current temperature, 5 p.m., Sunday, June 23rd. And notice we have colors that go from light yellow through dark red into pink. And they match up with the temperature scale down here. So we can see that if in Canada and southern Canada, maybe we're in the 60s, and we get down to here in Mexico, just about 100 degrees, just over 100 degrees. And so we go from cool in the north to warm in the south, which is exactly what we would expect after reading Chapter 2 and understanding how important latitude is in determining the amount of heat energy that reaches the Earth's surface, how dispersed that heat energy is, and how intense it is, depending on your latitude, and that is affected by the tilt of the Earth's rotational axis. So let's notice how these color bands are distributed on the map. Well, first let me explain about the color bands. The line between the bands are what we call isotherms. Those are lines that run through points of equal temperature. So if let's go between this orange and red, that would be about 85 degrees Fahrenheit or about 30 degrees Celsius. So the line between the orange and red is connecting points where the recorded temperature at 5 p.m. today was 85 degrees Fahrenheit. If we go into the orange, then we know that we are in the low 80s, and if we go into the red, then we know we're in the high 80s. Those lines are called isotherms. It means constant or equal temperature. And so what they've done is colored the region in between the isotherms so we can read the map more easily. So how are these lines distributed in the United States? It's pretty clear that the lines mostly run east-west. So we are going to see that globally isotherms tend to run east-west, and that is demonstrating that cooler temperatures at northern latitudes in the northern hemisphere, warmer temperatures at more southern latitudes in the northern hemisphere. But we see some different things happening on this map in the United States for today. Notice over here on the west coast, those isotherms are drawn down. So that means we're pulling cooler temperatures down further south. And the same thing happens here in the Rocky Mountain region. We're pulling those cooler temperatures down towards the south. And what we're going to learn about in Chapter 3 is how there are some different temperature controls that can affect temperature distribution besides just latitude. And so what I want you to do is look at this map, have a little bit of a think about what it is that might be happening to draw those cooler temperatures down here on the west coast and in the Rocky Mountain region, and then notice how the isotherms are a little different over here too. We have a cooler region down here as well. So have a think about that, and I'll be back in a bit.